Okay, so our second example is a little bit more complicated. This is nicotine. We've opened up the nicotine.hin file in Jmol and we're going to have a look at its structure. Now you can see nicotine has two rings that are connected together. So we've got an aromatic ring over here and we've got a 5-membered ring on this side. Looking carefully at the structure of nicotine, there is only one chiral center, and it's this carbon here. So how are we going to go about prioritizing the substituents on this carbon? Well, first of all, we can do what we did with glutamate. We can find the lowest, which is obviously the hydrogen, and the highest, which is the nitrogen here. So far, so good. But again, we're faced with this dilemma of what to do about the carbons. So we'll do what we did with glutamate. We'll work our way along the chain and find the bonded atoms with the highest atomic number. So let's start at the chiral center. We'll move to the substituent, the immediately bonded carbon on this side, and you can see that the next highest atom that we could move to is a carbon in this direction or a carbon in this direction. So again, we'll have a look at the other substituent, carbon. Fairly straightforward here. We can only move one direction, so we've got a carbon. So at this point, the two substituents are actually still matched with one another. So we have to move further along the chain. On this side, the next substituent is a nitrogen. If we went this way around, it will be a carbon still. But as we always go with the highest priority route, we'll take this one and we've got a nitrogen. This carbon here, the highest atomic number atom that's bonded to it is another carbon. So that's our difference. This side has a higher priority than this side here. So we've identified the priority of the substituents. Next task is to rotate the molecules so that the lowest priority, the hydrogen, is facing away from us. And that's quite simple. We'll just tip it up and try and move it so that we can see the substituents still quite well. So again, we've got our triangle of substituents, and we've got to have a look to see what order they are around the central chiral carbon. So remember, this was our highest priority substituent. We said this carbon here was the next highest because we got to a nitrogen quicker than we did with this one. So the order is nitrogen, this carbon, and then the carbon down here. So this molecule again is in the sinister configuration, and that's because the substituents go anti-clockwise around the central carbon. Just a little word about the nitrogen here. So we've got a nitrogen with 3 groups attached to it. Nitrogen can take a proton and become protonated, and that would make the nitrogen chiral. However, in the unprotonated situation that we have here, we've got a pair of electrons, a lone pair, and they can switch around with this group here fairly easily. So although nitrogen can display chirality, it only does so when it's protonated or otherwise has 4 substituents on it. When it's just got the lone pair and 3 substituents, the chirality changes so much that you can essentially regard it as being achiral. So to summarize, we've got S-nicotine here because we've got nitrogen, carbon, and then a lower priority carbon in an anti-clockwise direction around the chiral center.